Rational expressions. What that means is an expression, variables, in a rational format. Rational stands for fractions. So we're talking about variables in fractions. What we're going to try to do is we're going to try to simplify them, whether it be one fraction, two or more fractions that are being multiplied, or two or more fractions that are being divided. The first step, no matter which of those situations we're looking at, is we're going to factor each numerator and denominator. Then cancel any matching factors. It's very important that you do this in the right order, because a lot of times I have students who are trying to cancel before they have factored, and it doesn't work the same. So we want to factor each numerator and denominator, then cancel any matching factors. You cannot cancel pieces that are chained together. Parts of a polynomial, terms are chained by a plus sign or a minus sign only. So for example, like right here, I have an x squared minus 25. I could never just cancel this 25. It is chained together with the x squared. They stay together. But maybe I could factor it, and then I can work with smaller values. I'll show you what I mean. All right, here's some tips for factoring, because basically every one of these problems is factor, 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 and then cancel. So you're going to look at every numerator, every denominator, factor what you can, and then cancel if something will cancel out. So the first number one absolute positive step when you are going to factor, as you look at it and ask yourself, is there a common factor? Is there something that I can divide both or all of these terms by equally? So if they all can be divided by 2, or a 7 and an x, that would be 7x. That's what we're going to be looking for. If after you've checked for a common factor, you see that you still have 3 terms, that's when we're going to mainly look towards 2 sets of parentheses. If I have a situation like this, that's when I ask myself, what 2 numbers multiply to give me 8, but add up to 6? All right? This is getting kind of light, so I'll hold off on that. Then we have a third type that you will see very often, and it is called a difference of squares. Sometimes, more formally, it would be called a difference of 2 perfect squares. And that's when we have a situation like this. Here's a difference, because it's a subtraction. X squared is x times x. 25 is 5 times 5. So this is a difference of squares. So what I'm going to do is factor it into an x plus 5 and an x minus 5. You can come in.
Okay.
All right. 4x squared is 2x times 2x. 9 is 3 times 3. So it's going to factor into 2x plus 3 and 2x minus 3. The final one that you will see quite often, you have to be careful of, is when the terms are in the wrong order. 6 minus x, the x should always have come first. So what we're going to do is just flip them, okay? And it's not going to be the same. Let me show you why. If these are in the right order, that negative sign goes with the x. So that is negative x plus 6. These are equal to each other. They are exactly the same. But it's not appropriate to have a negative sign in front of the x. So we're going to factor that out. That's actually a common factor. We're going to take out a common factor of negative 1. So let's take out the negative 1. And what's left? Well, when I take out or factor, it's the same thing as divide. When I take out a negative 1, I'm left with a positive x. When I take out a negative 1, I get a negative 6. So these are the same. 6 minus x is not the same as x minus 6. It's the same as x minus 6 times negative 1. So the shortcut would be, if you see 2 terms that are in the wrong order and they're over a minus sign, you can just flip them and make it x minus 15, but you have to put that negative 1 in front so that they are now equal. All right, let's use this in a problem. Examples. 2x plus 30 over 8x plus 16. The first thing I do is I cannot cancel this 30 and this 16. I could divide them both by 2, but you're not allowed to do that right now because that 16 is a piece. It is chained to the 8x. That plus sign and that plus sign chains those two together. Same with the 30. It is chained with a 2x. So either I take out the whole 8x plus 16 or I don't touch it at all. But I could factor it. So let's look at just the numerator. 2x plus 30. There is a common factor of 2. I can divide them both by 2. So we write a 2 on the outside, draw some parentheses, and we ask ourselves, what do I have left when I divide them both by 2? Well, I'll divide that by 2 and I get x. I write the plus sign. 30 divided by 2 is 15. Do you see if I used the distributive property, it would multiply back out? 2 times x is 2x. 2 times 15 is 30. So they are equivalent, but they are in factored form. All right, 8x plus 16. I can divide them both by 2. I can divide them both by 4. But even better, I can divide them both by 8. So let's take out the 8. Divide by 8 and I get x. Divide by 8 and I get 2. Now the question is, what could I cancel? Well, this 2 cannot cancel with this 2 because this 2 is chained to the x. Either I cancel it with a whole x plus 2 or I don't touch. All right, so no touching. Can't mess with that. But this 2 can go into this 8. So let's see. 2 goes into itself once. 2 goes into 8 4 times. And I have a final answer of x plus 15. I can write the parenthesis or not, but this one I should. I have a 4 times an x plus 2. And there's my answer. You do not have to multiply it back out. That's one of the nice things about these problems. You can leave them in what we call factored form. All right, so let's try another one. Let me get green. Now, number 2, the numerator. Is there a common factor? No, there isn't. But I do have 3 terms, so that would be number 2 on my list. I'm going to try to factor it into 2 parentheses. X squared is x times x. What 2 numbers multiply to give me 15 and add up to 8? That would be these 2 right here. So 3 and 5. And it's a positive 8, so it would be a plus 3 and a plus 5. Now let's look at the denominator. 2 parentheses. Again, no common factor, so I can go right to the 2 parentheses. X squared is x times x. What 2 numbers multiply to give me 10, but subtract to give me 3? Well, 10 is 1 times 10. 1 and 10 subtract to give me 9, so that's not a 3. 10 is also 5 times 2. 5 and 2 subtract to give me 3. So let's do a 5 and a 2. To get a positive 3, it must be a positive 5 and a minus 2. Now, again, this x is chained to the 2, so I cannot cancel this x. All of these are chained, but like I said before, if you can either cancel the whole thing or don't touch it at all. Well, I can cancel the whole thing. X plus 5 can cancel with x plus 5. And I am now left with an x plus 3 over x minus 2. And that would be my final answer. And so let me go ahead and put a box around that one for you. All right, so let's scooch back and try the next one. Pick a new color. Go blue. All right, first question is numerator. Is there a common factor? I can take out a 5. Yes. Anything else I can take out? I can take out an x. They both have an x in common, so we're going to take out a 5 and an x. What's left when I divide this by 5x? I just have an x. When I divide this by 5 and x, all I have left is a 4. 20 divided by 5 is 4. All right? What do these two have in common? Remember, I'm not looking for something that these have in common with these. It's look at the numerator first, then look at the denominator. The denominator, I have a 10 in common. So I can factor out a 10. When I take out a 10 or divide by 10, I have left an x, then a plus sign, divide by 10, and I have a 4. Oh, this is nice. I have an x plus 4 in common with both of them. They can cancel. There's something else that can cancel. 5 can go into 10. 1, 2. So what is my final answer? In the numerator, all I have left is an x. In the denominator, all I have left is a 2. All right, next. Let me zoom through some of these so I don't go too long. All right, numerator, common factor of 5. So, I'll use this one. Oh, I can use orange. It's far enough away from the blue. All right, 5 times x plus 4. Now, be careful. This denominator, we talked about this before. Right here, number 4. I hope you can see that. It's all over the place. It's backwards, okay? The values are backwards in the denominator here. You have 3 minus x. The x needs to be first. So if I want to flip it to make it x minus 3, I have to put a minus 1 in front. All right, this numerator has a common factor of 3. This denominator has a common factor of 10. Now, how is this different? I just started working this problem, but I forgot to mention, this is a slightly different problem. This was 1 fraction, 1 fraction, 1 fraction. But we're just simplifying. This is 2 fractions being multiplied. The rules are exactly the same, as long as you recognize that any factor in a numerator can cancel with any factor that matches in a denominator. It doesn't have to be straight up and down. So, for example, I see an x minus 3 over here, and I see an x minus 3 up here. One's in a numerator, one's in a denominator. They can cancel. I also see a 5 that can cancel into a 10. I'm going to catch that over here. That was also the same thing. 5 goes into 5 one time, 5 goes into 10 2 times. What is left? I have an x plus 4 and a 3 in this numerator. Again, I did say you don't have to multiply it out. So I have a 3 times an x plus 4. In the denominator, I have a negative 1 times a 2 times an x plus 5. I should go ahead and write negative 2, but that's all I have to worry about. And that is my final answer. Now, next one. This one's a bit tougher, so I thought I'd throw a really good hard one at you. I see a common factor of 8x squared. When I take out an 8x squared, I have an x, I have a minus sign, and when I divide 8x squared by 8x squared, I get 1. These have a common factor of x squared. When I take out an x squared, I have an x, and a plus, and a 5. All right, these can be factored. There is no common factor, but I have 3 terms, so I could break them into 2 parentheses. X squared is x times x. What 2 numbers multiply to give me 20, but subtract to give me 1? 5 and 4. To get a positive 1, I have a plus 5 and a minus 4. This has a common factor, though, of 4. So what I'm going to do is I'm going to be a little sneaky. I'm going to just take out the 4 first. That leaves me with x squared minus 5x plus 4. So I have the 4 from here, it comes straight down. This can still be factored into 2 parentheses. Tricky. All right, x squared is x times x. What 2 numbers multiply to give me 4 that add up to 5? 4 and 1. To get a negative 5, they are a minus and a minus. So let me get the black one. I got a lot of stuff here. Let's see what we can cancel. One at a time. Any matching pair that's in a numerator and a denominator. I see an x minus 1 and an x minus 1. I see an x minus 4 and an x minus 4. Oh, I've got my arrows or my lines going in different directions. Sorry about that. I have an x plus 5 and an x plus 5. I have an x squared with an x squared. This x squared is not chained to this 8 because there's no plus or minus. The chains are a plus or minus sign. So it's free to get canceled out. And finally, I have an 8 and a 4. 4 goes into 4 one time. 4 goes into 8 2 times. And in all this fun mess, I have a final answer of 2. Oh, I like that problem. All right, and one last thing. Whoops. Fall off the chair. Okay, very quickly, I just wanted to show 2 things with this. Number 1, these are simple problems that we've already quizzed on. We talked about it with exponents. If you want more help with these, look at the exponents video. That should still be up on Edline. All right, but the same rules apply. You can cancel a numerator with a denominator, but we have an issue. We have a division. When you divide by a fraction, it is the same thing. As multiplying, let me try to fix this 16 so you can see it, by the reciprocal. So you have to change, you might have learned keep it, change it, flip it. Keep this fraction as it is, change it to a times, and flip the second fraction. That's multiplying by the reciprocal. Now I can start canceling things out. 7 goes into 21 3 times. 8 goes into 16 2 times. Now, when you get a mess like this, you could start canceling, or it might even be easier to do this. Let's just multiply straight across. I have an x and an x squared, which gives me an x cubed. I have a y squared and a y squared, which is a y to the 4th. In the denominator, I have a 3. I have an x. I have a y times a y cubed, which is a y to the 4th. That might make it a little easier for me as opposed to canceling things out. I see I can cancel this x with this x. Then I'm left with this x squared up here. So you would get the same answer, but this might make it a little simpler. And then now I can just simplify. Remember, when you divide, you subtract powers. X to the 3rd divided by x to the 1 is an x to the 2nd. Y to the 4th divided by y to the 4th is a y to the 0. In other words, they'll cancel out. And that is my answer. But let's do one of the full out ones real quick. Last one. Difference of 2 perfect squares. X squared minus 16 is x plus 4 times x minus 4. Common factor of 12. 12 times x plus 3. Now, the issue I have is this one needs to get flipped. Oh boy. Let's make it times and flip it. Now I'm going to do one extra step in here. Do you see that this one has a common factor? Then I'm probably, since there's 3 terms, going to have to break it into 2 parentheses. So I'm going to go ahead and take out the common factor of 2 right now while I flip it. This gets moved to the top, and I'm going to take out the common factor of 2. let's keep going. X plus 4 times x minus 4 all over 12 times x plus 3 times. Now, this does factor into, let's see, two numbers that multiply to give me 18, but subtract to give me 3. That would be 6 and 3. I want a negative 3 out of this. That would be a minus 6 and a plus 3. The denominator will factor into, there's no common factor, so it's 3 terms. X squared is x times x. What two numbers multiply to give me 32, but add up to 12? 1 and 32, 2 and 16, 3, no, 4 and 8, 4 and 8. To get a negative 12, though, it's a negative 4 and a negative 8. Again, remember the first rule that I gave you. Factor every numerator, every denominator, then you can start canceling. So I didn't do any canceling until I had gotten to this point. Now let's just see what we can cross off. An x minus 4 with an x minus 4. An x plus 3 with an x plus 3. 2 goes into 12 6 times. And so my final answer is I have an x plus 4 times an x minus 6 over, I have a 6, and I have an x minus 8. Again, this 6 cannot cancel with this 6 because this one is chained to the x. So I'm done. It's my final answer. Some of them can be nice and light, and some of them can be pretty complicated, but follow the path and the rules, you should do fine.